This is a video capture of the Mini Lab on Faraday's Law. Again, something that's probably much better if you can have students do if you have the equipment to do it. You can also do this in the PhET simulator, but I'm going to show you the version that shows up in the teacher notes. So I have a single bar magnet, a single solenoid, and that solenoid is connected to my ammeter to allow me to see which direction current is flowing that I induce within this coil. So if I get a positive current, that means current's going to be coming out of the right end of my solenoid. And you can't tell on the video, but the windings of a solenoid go from the red around the backside and then up in front, and it's wound around that way all the way down so that it finally comes up here in the front and then goes out the black lead there. So as it notes in the teacher notes, one good thing to do with this is to have folks make predictions for each of those scenarios. However, because it's difficult to see the individual windings here on the video, I'm not going to do that. Rather, I'm just going to demonstrate what happens, but you can reason about what would happen if you pause and make predictions. So here's my north end. If I put my north end into the solenoid, notice that I induced a current that flowed positive to negative on my meter. If I pull that north end out, I get a current that flows in the opposite direction. If I do it really slowly, there's very little current that is induced. Whereas if I do it quickly, I can get a much larger current, and I can almost pin the needle on this. So then you can ask students what happens if we reverse the magnet. And you'll note that as we reversed the magnet, everything flipped. The direction of the induced current was first negative and then positive. We can go back to our original orientation and instead turn the solenoid around or reverse the leads on the solenoid and make similar observations.